In this video, we're going to talk about the concept behind buffer systems in acid-base chemistry. So a buffer system is one that resists change in pH, and we'll talk about how it does this in just a bit. But if you take some water, which is pH 7, and add some acid to it, the pH might drop, for example, all the way to 4 or even lower, because there's nothing in the water to absorb the H+. The H+ just goes into the solution and drops the pH. Same goes for hydroxide. If you add sodium hydroxide to just water, then every hydroxide just winds up floating around as hydroxide, and the pH goes up quite a bit, maybe 10 or so. A buffer, something else entirely different happens. If you add hydrochloric acid to a buffer, there's actually some base compounds in that buffer that react with that hydrochloric acid, and basically, instead of having all the acid you added floating around, lowering the pH, it more or less reacts with that acid, and the pH does not drop as much. So a typical number might be a drop in pH of about 0.1 unit. Conversely, if you have a strong base that you're adding to your buffer, well, there's also a weak acid in the buffer system that reacts with hydroxide, and the pH might go up, for example, by 1/10 of a unit or so. Okay, so you can see the changes are huge for adding acids or bases to water, but the changes are very small for adding acids or bases to a buffer. And this is why it's called a buffer, because the buffer kind of insulates the solution from the effects of adding strong acids or strong bases. And so one of the particular important buffer systems is our blood. Our blood pH has to be within 1/10 of a pH unit for us to be alive. If the pH of our blood goes down by 1/10 of a pH unit, we will die from a symptom called acidosis. If a blood pH is 0.1 unit too high, then we'll get alkalosis, which is basically a blood pH that's too basic. And this is controlled primarily through carbonic acid. So if you hold your breath, then carbon dioxide starts to build up in your bloodstream, and carbonic acid, of course, is going to lower the pH of your blood. However, it's a buffered system, so pH drop is not going to be nearly so much. But eventually your body reaches a point where it's an involuntary sort of thing. You're going to pass out and start breathing again, whether or not you think it's a good idea. If you're underwater, it's not a good idea. So the opposite is if you're hyperventilating, you're removing too much CO2 from your bloods too quickly in your lungs, and so the pH starts to rise too high. And so the remedy for that is basically when you pass out, you start breathing normally, and then everything kind of takes care of itself. Okay, so let's do the examples of the actual buffer systems I talked about. And so if you have hydrogen carbonate and carbonate and H2CO3, okay, all of these are in equilibrium, but at the blood pH there's going to be significant amounts of hydrogen carbonate and some carbonate. So the carbonate is going to react with any acid that you add to produce hydrogen carbonate. The hydrogen carbonate is going to react with any hydroxide that you add to give carbonate. So that's how buffers work. It's a combination of a weak acid and its conjugate weak base. So for example, this is the conjugate acid-base pair, where this is the weak acid, that's the weak base. At a different pH from our blood, for example, there might be something where this equilibrium between these two forms is more appropriate at much lower pH, where this is the acid and this is the conjugate base.